Right, we're going to take this procedure back the other way. We've just had the video showing how to sketch graphs of this form, y equals a times the absolute value of x minus p plus q. Now we're going to go the other way. So here's an example. Determine the equation of an absolute value graph with y-intercept 10 and vertex point 3, 4. Well, quite simply, we're going to reverse this and go that way. X minus p gives you p and q gives you q. So we're going to go back the other way. So we're going to end up with x minus 3 and plus 4. Notice the sign change because it's minus p there and that's plus 3 there. Now we need to find the value of a, and that's a simple case of substitution. So we're going to substitute 0, 10 into the equation because that's the y-intercept. 10 for y, 0 for x. That simplifies to 3a plus 4 equals 10. And we have a equal to 2. So there is our graph. Another example. Now it's just a pictorial definition of the graph. So now we have, once again, the vertex point or the salient point and the x-intercept. So we're going to go through the same process. We're going to take this, we're going to substitute 2 for q and minus 1 for p. So now we have x plus 1 there and 2 there. And now because we have the x-intercept of 5, we're going to substitute 5, 0. 5, 0 into the equation. 0 for y and 5 for x. Solving that, we end up with 6a plus 2 equals 0. A equals negative 1/3. And there's our equation. Confirmed, it's an inverted graph, so there's the negative, and it's flatter than 45 degrees, so therefore it's less than 1, the gradient. Another one, here we're not given the full vertex point, the full salient point, but we do have the y-coordinate of the vertex point. So now we can use symmetry. We can determine symmetry by symmetry because this graph is symmetrical about that line through the vertex point. We don't know the x value at the moment, but we know the y value is minus 3. So that distance is equal to that distance. So all we have to do is find the average between those two values. And we get x equal to 1, and now we have the vertex point. And we can continue using either one of those or either one of those x-intercepts in order to find the value of a. So we substitute p equals 1 minus 3, there's our vertex point. X minus p, so x minus 1 plus q, so therefore minus 3. And I'll substitute the value, the 0.30. I could have just as easily substituted negative 1, 0. It would actually give me the same answer. 2a plus a minus 3 equals 0. So a is 3 over 2. So there is our equation. And here's some exercises for you. Pause at this stage and try the exercises before you continue. Here are the answers to those exercises.